Hello guys, so welcome to another video on Blue Tech Empire Python tutorials. In this video, we are going to be looking at the membership operator. So the membership operator is very important when you're working with iterables or sequences. You can have a sequence and you have a few items within the sequence. You may want to check if an item is present in that sequence. So normally we use the membership operator. The membership operator, we don't have many membership operator, we just have a few of them. We have in and not in, you understand, just to check if an item is in a list or a tuple or a dictionary or a set or an iterable in general. But for now, we know only these iterables. There are a few other iterables we're going to look at in the future, or even how to declare your class as an iterable or a generator, for example. But for the meantime, I'm just going to be showing you with lists, tuples, dictionaries, and sets. And I think that's it. So let's move into the video. Mm. So membership operators are very important. We have used it already within a couple of our programs earlier in the previous videos. So for membership operators, let's just do some brief reading. Membership operators test for membership in a sequence, such as strings, lists, tuples, etc. There are just two membership operators in Python as shown below. So we have just two membership operators in Python. Now, we have in evaluates to true if it finds a variable in the specified sequence and false otherwise. So we are going to be looking at that right now. So like other operators we explained, a membership operator is also a binary operator because it has two operands, a left hand operand and a right hand operand. Let's look, for example, if we say 2 in the list 3, 5, 8, 1, 3, 2. Now, this is the in membership operator. We have in and not in. So we're starting with in. What will this operator actually do with its operands? As you can see, this operator has two operands. It has a left operand and it has a right operand. This operator simply checks if its left operand is found in its right operand. Note, we are using literals in this example. For example, we use the literal to and we use the least literal this. Now you can also use variables. Now let's check the result of this expression. Every statement in Python, we can call it an expression. It's a combination of statements. An expression usually returns a value. For example, this expression is a Boolean expression. The membership operator is a Boolean. It's actually like a Boolean expression because it can return either true or it can return false. If 2 is found in this list, it's going to return true. If 2 is not found in this list, it's going to return false. Now let's see. Now 2 in whatever list, enter, let's see, it gives us true. Now let's check, is 7 in that list? No, 7 is not in that list. So you see, a membership operator has only two possible return values, and those values are booleans. If you haven't watched the video on booleans we did earlier, you can go watch the video on booleans. A boolean object can either have a value true or a value false, and a membership operator, we can call it a boolean operator. Why? Because it can return either true or false. It's similar to the comparison operators, which we also call Boolean operators, because comparison operators can either return true or false. Same like the membership operator. Now, we use literals to 7 in this case. Remember, it can also be a variable. Whatever variable, in this case, I'm going to use some stuff. I'm going to use the name of an animal just to show you it can be any stuff. So we have dog equals to 23, and we have James list equal to 23. Sorry, James list equal to, all right, now we have James list 3, 6, 12, 31, 1, 8, 40, and let's say 23. Now let's say in addition to this, we have another variable called cat, and that cat is equal to, let's say, Ooh, 41. Now, let's check. Is dog in James' list? What happens? In this case, we have two operands, a left side operand and a right side operand. But these operands are not literals like we had in the past, where literals are just when you write a value directly into code without storing it in maybe a variable name or something. They are called literals, they are constant literals. So in this case, we assigned it to a variable. Here was a constant two, here is a constant list, all this stuff. You may not worry, but we just call them literals. So here we have a variable dog, we have another variable James list. Now in this case, Python is just going to find the value attached to dog, in this case 23. In James list, Python is going to replace it with this. So this is similar to writing um, 23 in. Here is similar. What we just did here is same as this, but these are variables. Why is it important for us to use variables? Like we have explained in previous videos, this may be coming from a user, or you understand, this may be coming from a user. Like I'm going to show you a brief program shortly. It may be coming from a user. Maybe you may have what we call a shopping cart, and individuals can buy, and an individual will enter its item, and you say if it's present in the cart or it's not in the cart. So we can do a lot with the in operator to check if an item is in a list. I'm going to show you that in a brief moment. So in this case, dog in James list, I think it should return sorry, it should return true because 23 is present in this James list. What of cats in James list? Let's check that. It returns false. So you see, we can just check. It's usually used to check if a variable or a value is within a sequence. Now we can do it both for lists or tuples or whatever. Now in this case, let's use the same stuff here so we don't waste a lot of time. Yeah, now look, if there was a tuple, if you haven't watched our video on tuples and you don't understand what tuples are all about, you can watch the video on tuples also. Yeah. So let's find if 3 is in the tuple, 3 in tuple. Yes, 3 is in this tuple, so it returns true. What of um is 10 in this tuple? No, it returns false. Now we have seen it for tuples and lists. Let's see it for dictionaries, or let's first see it for sets. Now here is a set, and remember we have been testing for just numbers. You can also test for any stuff. You can test for complex numbers. You can test for strings. You can test for booleans. For example, let this list have some few stuffs, fancy stuff. 6 plus 5j, and it should even have something like false. It should even have a tuple 4, 5, 6. Right? We know a set cannot contain an immutable item. We have done videos on all this. What I'm saying, we have videos on them. So a set normally cannot contain an immutable item. That's why I don't want to add a list to this set, because a list is a mutable item, and a set cannot contain immutable items. Sorry. So we can only have immutable items in sets. That's why I have these stuffs here. So like let's look 8.6. So now we have our list set. All right. So now let's finish it here. Remember, this is a set. Now is 10 in the set? No. What of is high in the set? We can also check for a string, not just only a high in sets. True, because here is high. Remember, it's case sensitive. So if we say high in set, it's not going to work. All right, so what of false? Is false in set? Let's check. So I just want to show you can check for any stuff. True. False is in set. Yeah, here is it. It's true in set. It may return true because, like from the previous video we did on Boolean expressions, you realize not actually borrowing from, I think, bitwise and logical operators. You explained that one true in Python is similar to one. So if you write true in this set, it returns true because though true is not here, one is equivalent to true. So it saw true, it saw one and return true because true is the same as one in Python. So one is in this set. Yeah, though the literal true itself is not there, but since true internally represents one, we have a truth value was returned or true was returned. Now we can also check if a complex number is in this set, like we did 6 plus 5j, true. So we can even check if a whole tuple is in the set 4, 5, 6, true. You understand? So we can check all these, any you can check if any um variable is within a list, any variable type. You can, like we've seen, we have checked for strings, integer, you can even check for floats if you want to just be sure. You can check for any variable type in a sequence. So it's false because 8.7 is not in the list. Now we're using a set, the sequence set. You can also use this, can still be a tuple or a list if you want. Now let's look at dictionary. Dictionary is a bit different here because dictionary is not just a list of items, it has key value pairs. So we're going to see how it works with its key value pairs. EMANUEL, let's say age, let's say 32, and let's say um let's just give some 401 401 401, the key 401, and let's give it a value true. Yeah, remember keys can be any immutable item, like we saw when we learned the video on the set data type. You'll notice a key to a dictionary can be any immutable type. So a number can be a key. Usually we use strings, but just know a number can be a key. A tuple can also be a key. Even a complex number can be a key, but usually most of the times you see dictionary with keys of string type. So let's move. Now 8.7 in dictionary, no. Now with a dictionary, when you use the in operator, it actually checks for the keys. Like I told you, each time you iterate over a dictionary, what you iterate over in a dictionary is the keys, not the values. So you can't say Emmanuel. You can, if, in fact, if you ask this, if you ask if age is in this list, it returns true because it's the key we are looking for. But now, if you ask if 32 is in this list like this, it returns false because iteration is not done with values. Even if you ask if name is in this, if you ask if the name Emmanuel, it returns false because iteration with the dictionary is usually done with the keys. But if you check if name, you can only check for the existence of a name, not a value. Yes, age, yes, 401, perfect. So you can check for the existence, but if you write true, it's going to return you, let's check, no, false, because true, there's no, though we have true as a value, no key, there's no key equivalent to true. Yeah, you see, there's no key with the value true. There's no key true. Let's put it that way. There's no key true. There's a key with the value true. There's the 401 key, but there's no key true. Let's put it like that. We have the key name, age, and 401. So now we have looked at the in. I've showed you several examples. So I guess by this point you fully understand how to use the in membership operator. Now the next membership operator is just not in, and not in is simply the opposite of in. So like in this case, if you say 8.7 not in, you're just trying to say 8.7 is not in this sequence, and the answer is true because there's no 8.7. But if you say something like 8.1, let's say if you say something like 40 not in this dictionary, it returns false because You saying 40 not in this dictionary is false because 40 is actually in the dictionary. So not in is just the opposite of in. If in returns true, not in will returns false. Let's say, for example, if there was a tuple, just to show you, you can do it with any sequence. So you don't think it's just dictionary sets. Now let's say hi, hi not in. This triple gave us false because high is actually in the triple, so this statement is false. Now if we set high in triple, it would have given us true. You see, so not in is just the opposite of in. I just wanted to see that and understand it. So there's no really big deal to not in. Most of the times, just know not in is opposite to in. So here are a few examples. We have a variable 9 in var 1. We return true because we actually have 9 here in the list var 1. 30 in var 1, is that 30? No, it returns false. Hello in var 2, do we have hello? Yeah, it's going to return true. 10.3 in var 2, do we have 10.3 here? No, it's going to return false. Now let's see this example here. Now look at, we have a list with a group of items, we have a tuple with a group of items, we have a set with a group of items. Now let's check. B equals to hello, yeah. C equals to 2, D equals to a tuple 1, 2, 3, C in list. We are checking if the variable C, what's C? C is 2, as you can see from here. Now C in list 1 gives us, is there 3 in list? Do we have 2? Yeah, it gives us true. Now we have 1, 2, 3 is the list 1, 2, 3 in the list in list 1. Yes, let's check this one. We see in list 1 we have a list 1, 2, 3. So the list 1, 2, 3 is in list 1, it returns true. Is B in list 1? What's B? Hello. What's list 1? Yeah, yes, B is in list 1. Is 35 in list 1? Oh, nope. There's no 35. Is high in list 1? Nope, no high. Is Paul in list 1? Nope, no Paul. Is Paul in tuple 1? Oh yeah, we have Paul. It's Lauren in tuple 1? Nope. Is 10 in tuple 1? Yep. Is false in tuple 1? If we had 0, it would have returned true because 0 is equivalent to false, just like 1 is equivalent to true. So nope, it returns false. Is 10 not in tuple 1? Yeah, no, that's false because 10 is in tuple 1, so it returns false. Is 1 not in set 1? 1 not in set 1, that should be false because 1 is in set 1. High in set 1? High in set 1. We had an error here, we did not do it properly. High in set 1. High in set 1. Yeah, we have high in set 1. 20 not in list 1. 20 is not in this one. Is that true? Oh, yeah. So it returns true. BTE not in tuple 1. Oh, tuple 1. Do we have any BTE? Oh, yeah. Yeah. It returns true. So I guess you understand now you understand fully how the in and the not in operator works. The in operator checks if a value is within a sequence. If it's a dictionary, it checks whether the key exists. A particular value is a key in a sequence in a dictionary, or while the not in is actually the opposite of the in operator. It checks if a value is not in a sequence and returns true if the value is not in the sequence, or false otherwise. So I guess it's very clear right now. So in the next video, we are going to be looking at Python identity operator. But before looking at that, I'm going to show you an example like of a very primitive password validation or authentication system. This system will be built with Python, just a brief system, not something complicated. We're going to build it with Python. It will actually check if a user is a user's name is recorded in the system. But first, let's write a simple program here where we have a group of items we sell in our shop. Um, a group of items we sell in our shop. Let's say items, and we sell cars. We sell. Let's just say car, or let's say cars. Let's say we sell dogs. Let's say we sell. Let's say we sell TVs. TVs. Let's say we sell phones. Phones. Let's say we sell computers. And finally, let's say we sell tires. Now we can and a user comes into our shop and it names his items or what he wants to buy. All right, let's start all this with capital letter. All right, let's not worry about the capital letter. Let's say we're going to convert to lowercase or uppercase. So let's say cars. All right. So now a user comes in, says what he wants, we check. So now we take input u request equal to input. User will say, what would you love to purchase from us? Now user comes and checks, what will you love to purchase from. Let's check if it does spelling correction. All right, there's no spelling correction here. So what will you love to purchase from us? Now we are expecting the user to give a response. So we take the response and we just simply check if. First, let's convert. I want us to convert the um, let's convert the user's input to an uppercase letter. Like, let me show you how we do it. Now we're gonna say user request should be equal to user request dot title. Now title just converts the first letter of an input to an uppercase letter. It helps us to match. It helps. We're gonna first say user request dot lower. Let's check the lower dot title. Now what we do is that we want, if the user enters a mixture of cases, we first convert it to a lower case. Let us put this as TV. All right, so let's use compute. Let's just use a tile. Let's use single, dog. All right. So what we want to do is, if the user enter a mixture of cases, we first convert all to lowercase, then we convert the first word to an uppercase. That's the use. The to lower will convert everything to lowercase. The title now converts the first letter to an uppercase. So for example, let's print u request. All right. Now look why I'm doing like that. Let's just look at some few examples so you see how it works. So let's say, for example, the user enter car. See, we have car. We converted everything to lowercase and we did the necessary correction. Let's say the user enters this car, CAR. We still arrange it for the user just so we can now use it to check in our list. So it's very simple now. Once we have this set, we can just say, once we have this set, we can just say now, if, let's not print this, we can just say if you request in items, print well welcome, we sell this, this, we add an s to it. Now we add an s to it, then write the format, we sell you request. Now else, if we don't have it, we're gonna tell him, print, or her, sorry, we don't sell this. First we add an s to it, we say dot format user you request. Now here is an example. We just tell the user. Now let's see how it works. If the user enters car, oh, I'm somewhere else. I was somewhere else. The user enters car. Wow, I'm still there. Yeah, if the user enters car, we have welcome, we sell cars. If the user enters, let's say, he enters like clothes. Sorry, we don't sell clothes. So that's an example of how you can use the in operator just to check if an item is in a list. Next example, we're just going to look at a simple example where we have a group of username and password. For example, let's say we have three users in our server. Um, it's in the dictionary, their name. We have username Emmanuel, password 2345. Let's say A2345. That's his password. We have another user Miriam, and password is let's say 5EES, and we have a last user James, and their password is his password is let's say James U. Very easy password. All right, now we can tell the user, welcome, please authenticate to have access. Welcome. We can even say message. Let's just have a message. Message equals to to Blue Tech Empire. Please log in to continue. Or let's just print this. No need to save it as a message. Print log in to continue. The next term we say uname equals to enter input, enter user name, and we can have keyword equal to input, enter password. And next we can have now the user enters the username password. Now it's simple for us. What we do is we check if that username exists by checking if, when we use the in operator with a dictionary, we check the key. Now if now we're going to use another operator we learned earlier, the and operator. If users in uname in users and users uname is equal to, you can use brackets to separate this so you know what you're doing. Just like see users and users uname equal to let's say user uname equal to password. Very easy. If you haven't watched the video on dictionary we did, you can watch our video on dictionary so you understand how to access dictionary values using the keys. So equals to p-word. Now we say print welcome, you are now else. Let's see, else we just write invalid user name or password. Please try again. Very easy. Now in this case, let's see an example. All right, so if the user enters Emmanuel, enters password, some random password, invalid username or password, please try again. We enter this time we enter Emmanuel and I will enter the password A2345. Welcome, you are now fully authenticated. Let's say we use the username James. Sorry, we use the username James, and we use James, and the password we use some stuff wrong. Invalid username or password. Let's say now we use James, and we have the correct password James U. Welcome, you are now full of text. So I just wanted to show you that. That's an example of how you can use. Now we use the Python, I think, logical operator, and we have and, or, and not. We use the and operator to check if this, to only print welcome, you are fully authenticated, maybe, and deliver whatever you want to deliver to the user, only if this is true and this is true. Now this statement, it checks if this the key that the user is going to enter a username. It checks if a key exists with that username. It checks if a key exists. You know, when you iterate through a dictionary, like I explained earlier, you actually iterate over the keys. So when the user enter Emmanuel, it's going to say a key, and it's then going to check if users Emmanuel is equal to whatever password the users followed by the key is accessing the dictionary keys. It returns the value. So we're going to check if that value returned is equals to the password entered by the user. So that's a very simple way you can use to store. If you're using Python, maybe you're using a framework like Flask, Django, you may come across something like this because you're going to be representing database data with dictionaries. So it's likely you're going to do this sometime. Sometime we're going to also learn in this channel, we'll have to learn the Flask framework. So you learn how to create web applications using Flask, and obviously we'll do things like this during that time, but that's some later time. All right, so here is just an example of how you can use. We're going to learn the if else branching statement later. So if you don't understand it, don't worry. I just wanted you to see how we can use the in operator to go through dictionary keys and then access that value to check out a few stuff. So that's it for this video. In the next video, we are going to look at the Python identity operator, which is also not very long. Yeah, so see you soon and have a nice time. All right.